CEO Secretary Company, selecting table on the point to also Mr. Mukherjee, Mr. Bora. We are also part of the two national projects of 100 kV national test station and India's first smart city pilot project in Pondicherry. We are project steering committee members in both these projects. The subject is partially and fully insulated conductor system for low and medium voltage overhead distribution line. Partially insulated covered conductor and fully insulated ABC systems, that's aerial bundle conductor systems, are increasingly emerging as popular alternative to bare conductor systems for low voltage and medium voltage category to minimize pilferage and line outage in order to achieve better availability and reliability of overhead electrical power distribution systems. We have shared our experience of design and development of important components of the system, validation by laboratory test and field experience after installation of lines, concept, features, development history, validation, advantages and limitations of insulation piercing connector have been dealt in detail. Significant environmental benefits like conservation of trees, minimizing risk and hazard while passing through highly congested areas can be achieved by adopting aerial bundle conductor system, which also permits high voltage distribution lines to pass through narrow alleyways and slums without allowing illegal tapping. However, proper design and quality of systems as well as accessories should be done to take care of current carrying capacity through conducting part and to provide sound insulation. Aerial bundle cable system, which is an insulated system, was introduced in low voltage to provide certain advantages as shown below. Traditionally, overhead distribution lines have all been on bare conductors, where they are insulated from ground by using polymer or glass or ceramic insulators. So gradually, now the conductor itself are provided with various stages of insulation. The advantage in low voltage system to provide over bare conductor systems are substantial reduction of line outage, improved reliability of the system, reduction of cost towards energy not supplied, safety of people and cattle, reduction of leakage current, reduction of general bushfire, conductor being bundled together, no face-to-face or face-to-earth clearance is required, reduction of right-of-way, which is a very serious issue all over the world and it becomes so in India recently, obviation of tree trimming and reduction of maintenance and its cost. In case of medium voltage, another type of non-bare conductor systems are in use in different parts of the world because medium voltage aerial bundle conductor, which is fully insulated system, is a very expensive system. So to achieve the optimum cost benefit binomial, another kind of non-bare conductor system is increasingly used in different parts of the world. This system deploys covered conductor but unscreened, which provides a protecting cover on the conductor. This cover on the conductor does not provide complete rated insulation and hence also not touch proof, but help in achieving reduction of spacing between conductors and compacting of the line. This system also helps in minimizing frequent flashover and line outages on account of accidental contact of phases or contact through hay leaves, though varies due to growth of trees. With the improved performance against waterproofing and arc protection, this system provides better safeguards against damage to covering from training and lightning strikes. See, this system was giving very good performance until some lightning strikes were observed and where the damage to the insulation was, covering was taking place. So subsequently various arc protection and surge protection mechanisms were provided where the arc was guided to, where the lightning arc was guided to designated arc protection devices and that has resulted in substantial improvement in the outage performance. High voltage distribution system where lines are drawn right up to consumers, small single phase transformers are operated at medium voltage. In this system, LV mains are conspicuous by their absence. This system is very important to prevent theft, where low voltage tapping results in a lot of threat of power. India, as we all know, has very high degree of efficiency losses, and one of the challenges for the distribution grids in India is to curtail this process and to bring it to international level. MV-ABC system with fully insulated metallic screen has been used in India mainly in HV high voltage distribution systems. Internationally also this system is regarded as the most economic solution, particularly where constraints on availability of wheelie clearances exist, and also where bushfire risk with overhanging trees exist, and in highly congested localities where obtaining live metal clearances is a bottleneck, and where vulnerability to power threats exists. See, there are certain areas, plus highly congested areas, where you cannot dig trenches for underground cable, and you cannot provide any kind of vertical or horizontal clearance or face-to-face clearance, because they are very extremely narrow alleyways. There, this is probably the only effective solution which prevents theft and which makes it possible to make high voltage lines to be taken to individual consumers. These cables are shielded and screened, and the insulation is designed and tested to function at full operating voltage. The different layers of insulation, voltage, stress relief, anti-tracking, and metallic shield provide a designated path for charging current during normal operation and fault current during insulation failure. Voltage stress relief terminations at every point, termination and tapping point, are of importance, and proper design, selection and testing methods are followed. The challenges for adopting the system generally are, from installation point of view, key joints are to be made at junction points of discontinuities, and from organization and management point of view, switching and earthing process are quite different from wire conductor technique. This is more or less similar to underground cable system. Moreover, accessibility for earthing system maintenance and conductor testing becomes a challenge. This calls for some specialized and extensive training to be imparted to the erection and OM personnel. See, normally those crew or the people trained for overhead line constructions, they are not accustomed to a technique which is typically used in underground installations. The first country to adopt cover conductor line was Finland in 1984. The most followed technical standards were Finnish standards, SFS 5790, 5791 and 5792. These apart, Australian and New Zealand standards 3675 are followed for covered conductor system and hardware and accessories. In Australia, Brazil, Ireland, Norway, Slovenia, South Korea, Sweden, UK, and few more countries, medium voltage covered conductor system and ABC installation system were also adopted initially on trial basis and subsequently on regular basis. Metal screen ABC system having fully insulated component has limited usage since it is quite expensive. It has been deployed to places where high voltage distribution system lines are bound to be taken through restricted passages near congested areas and buildings, sites having other obstructions. In such cases, public safety and safety to touch requirement prevail the requirement over cost effectiveness. In India, this system has been installed by a number of utilities since it is safe and advantageous to take HVDS line through slums for connecting to small capacity single phase transformers. Covered unscreened conductors are most commonly used as outage-free alternative to bare lines. In North America and Brazil, they use composite insulated interface spaces to maintain horizontal separation. In Europe, system has many designations based on protection, arrangement and voltage rating. According to study published in T&D World in November 1997 by Soros of 7, system operating from 5 to 6 years faced only 2 accidental outages. The conductors ruptured due to failing object from the building and the extended rubbing of the covered cable against T-branch. While main advantages are narrow corridor and negligible outages, on the flip side it still needs vertical clearance on the bare lines as the system is not touch-free. Another system finding increasing acceptance is MV bundle system with a semiconductor outer layer with no metallic screen and a bare messenger wire. The touch-safe property of the bundle is achieved by connecting bare messenger to the earth. This system has been found attractive in Ireland based on feedback of Australian experience. This drastically